This is Sarah Weber, Sustainable Packaging Engineer at Plastic Ingenuity. Welcome to Lesson 4 of our course on sustainable packaging. As packaging professionals striving for sustainability, we know that every design choice matters. Today, we will dive into the topic of design for sustainability. In the first lesson, we learned that sustainable packaging is defined by any form of packaging where a conscious, significant effort has been made to reduce the environmental impact of the package. This includes the ability of the packaging to increase shelf life, reduce spoilage, damage, breakage, and waste of the packaged products. Designing for sustainability starts by discussing the waste hierarchy of reduce, reuse, and recycle. According to the Sustainable Packaging Coalition, 70% of the overall impact of a product is determined in the design phase. When it comes to packaging, adopting a reduce, reuse, recycle approach is crucial for sustainability. So, let's define what the key components of the waste hierarchy are. Let's start with reduce. As the first tier of the waste hierarchy, reduction is the most environmentally preferred strategy. It involves reducing waste at the source. Examples of source reduction include downgauging of material, decreasing the geometrical footprint, or right-sizing a package to reduce empty space. Source reduction helps save resources, energy consumption, and money. The best way we can evaluate if a package can be reduced is to challenge test the package until failure. For example, a packaging engineer can create multiple iterations of a package at different material gauges. From there, the engineer can conduct their normal distribution testing protocol to determine if the gauge at which the package fails. Once a failure point is established, the engineer knows the lowest material gauge of the package they can use without it failing. To achieve what we call the optimal package design, we must minimize the material usage while ensuring the protection of the product. During the design process, it is important to inspect each design element of the package for potential reduction opportunities, such as evaluating material choices, tolerances, and other features that could impact the environmental footprint. Similarly, challenge testing can be done on secondary, tertiary, and distribution packaging to maximize pack-out efficiencies and pallet designs. It is important to remember that the goal is to create a safe package that minimizes material usage but does not compromise reliability. A package that does not protect the product is simply not sustainable. The second tier of the waste hierarchy is reuse. The Sustainable Packaging Coalition defines reuse as packaging that allows either the business or the consumer to put the same type of purchased product back into the original packaging. It is designed to be returnable and/or refillable, and it accomplishes a minimum number of reuses while being part of a system that enables reuse. It is important to note that reusable packaging can be very effective for certain product types, but it may not work for everything. There are many aspects to reusable packaging that need to be done in place to make it work well. In a report from Smithers, they break down the critical success factors of reusable packaging into 4 key points. The reusable model must be optimizing convenience for the purchaser, carefully balancing price and functionality, creating consumer incentives, and linking seamlessly into integrated logistics and tools. When a reusable packaging system is designed holistically with these factors in mind, there is a high likelihood of success. SPC has determined a list of products that may benefit from reusable packaging. These products include food service containers that are frequently purchased items for home care products or work, or online purchases where the products are often returned, such as clothes or footwear. But in order to make a reusable packaging model work, it must be designed sustainably. It is crucial to perform a life cycle assessment to determine if the reusable model will be more environmentally friendly than single-use packaging. The number of times a reusable package is returned is directly correlated to the environmental footprint of the packaging system. Based on SBC's position statement on reusable packaging, the return rate of a package should achieve 80%, if not 90%, to achieve environmental benefits. The lower the return rate of the package, the greater the environmental impact of the reusable package will be. Although it is not required to design a reusable package for recyclability, it is recommended because the consumer may not participate in the reuse model. And while we're on the topic of recyclability, let's jump into the last tier of the waste hierarchy. This is recycling. Designing for recyclability is a main focus for many brands as extended producer responsibility legislation becomes a reality. This has pushed suppliers, converters, and manufacturers of single-use packaging to integrate design for recyclability criteria into their development process. Recycling is the process of collecting and processing materials that would otherwise be thrown away as waste and remanufacturing them into new products. One may ask, why is designing for recyclability so important? The main reason we design for recyclability is so that the package may be collected, sorted, recycled, and subsequently used as a raw material instead of virgin fossil fuel-derived plastic. Now let's discuss a few statistics about recycling. In 2022, about 5 billion pounds of plastic packaging was recovered for recycling. However, this still left 28 billion pounds of plastic packaging available for recovery. As an industry, we must increase the amount of packaging that is recycled. Although there are many steps to recycling a package, such as collection, sortation, reprocessing, and developing end markets, we must first start with designing the package to be recycled. Now, when we are preparing for designing our package to be recycled, we must understand what the term recyclable really means. So let's define it. What does it mean for a package to be recyclable? Well, we must consider all 4 pillars of the practice of recycling: collection, sortation, reprocessing, and end markets. As best practice, the Association of Plastic Recyclers defines recyclable as 60% of consumers must have access to the collection, the item must be sortable into material bales, it must be processed in a cost-effective manner, and it must have end market value. A great resource to ensure your package design meets recycling guidance is by using the Association of Plastic Recyclers Design Guide. The APR Design Guide bridges the gap between designers and recycling systems, ensuring products are genuinely recycling compatible. The APR Design Guide helps package designers measure each aspect of a package against industry-accepted criteria to ensure that it is truly compatible with recycling. Commonly assessed design features include base resin, color, size and dimensions, closures, dispensers, barrier layers, coatings, additives, labels, adhesives, and inks. For example, when designing for recyclability, it is important to choose a base resin that is desirable for recycling, such as PET, HDPE, or polypropylene. The size and dimensions of a package are important due to the size limits of recycling machinery, particularly automatic sorting equipment within a material recovery facility. For example, if a plastic part is more two-dimensional than three-dimensional, it may have the likelihood of being sorted into a paper stream instead of plastic. The color of plastic packaging is incredibly important for recycling. Not only is it crucial to ensure the colorant used does not hinder sortation, but oftentimes natural or clear plastic is more desired for end markets of recycled content. These are all factors that we can assess, and luckily we have the APR Design Guide to break it down for us. The guide classifies features into 4 categories. APR Design Guide Preferred. These features enhance recyclability. Detrimental to recycling. Features that hinder recycling, but not make it impossible to be recycled. Renders package non-recyclable. Design elements that make the recycling impossible. And requires testing. Features needing further evaluation. As the final tier of the waste hierarchy, recycling plays a critical role in designing for sustainability in packaging. When we design for recycling, we ensure products never become waste and allowing for closed-loop material recovery. The more we recycle, the demand for investment in recycling will increase, thus reducing the amount of solid waste accumulated, raw material used, and energy consumed. Altogether, this contributes to lowering greenhouse gas emissions and promoting a circular economy. The Sustainable Packaging Coalition states that effective sustainable packaging needs a holistic design strategy. This means identifying opportunities for elimination or reduction, evaluating sourcing practices, optimizing for efficiency in transport, and working towards material health. We've already identified strategies for elimination and reduction and optimizing for efficiencies within the waste hierarchy, but let's discuss the importance of material selection in sustainable packaging design. As discussed in the life cycle assessment and sustainable materials lessons, certain materials have different environmental footprints. Choosing materials that are well suited for recycling is incredibly important, but incorporating recycled content is equally important. Introducing PCR into packaging keeps valuable material out of our landfills so it can recirculate in our economy. The demand for PCR also fuels the economic incentives our recycling industry needs to continue operating. Outside of the economic benefits, using PCR significantly lowers the carbon footprint of a package and reduces the use of virgin materials. Lastly, brands are discovering that using PCR can enhance brand equity among sustainably minded consumers. Designing for circularity is a crucial element in achieving sustainable packaging solutions. By creating products and materials that can be easily recycled, reused, or repurposed, we can reduce waste and minimize environmental impact. Circular design encourages closed-loop systems where materials are continuously circled back into production, reducing the need for virgin resources. However, it's essential to recognize that circularity alone isn't the sole solution. Other approaches such as lightweighting, source reduction, and composting play complementary roles in sustainable packaging. Balancing these strategies ensures a holistic and effective approach to minimizing our environmental footprint of the packaging that we produce. Thank you so much for attending this lesson on Design for Sustainability for Plastic Ingenuity's course on sustainable packaging. See you next time.